Oh, I'm back. Am I actually back? I just stop and start, right? It should work like that. Twitch. I should change this actually, Nick documentation. This is not, this is Lambda calculus. Lambda calculus. And. This will be about and. Lambda calculus and. Content, video producer. Next documentation issue PR, broadcasting. Why is this still broadcasting? Past broadcast. Oh, it's still stop. Broadcasting. I know it's this thing. Yeah, I'll just export this to YouTube. Next documentation issue PR, Nixos discovery, start export. So I want to look into Lambda calculus because, and it's great to understand Nix. It's really great. Let's do Lambda. Yes, this is the book. And we will use the Nix REPL. We will use the Nix REPL to try this stuff out. Oh, not true. Not true, not false. All right, a little bit of Lambda calculus. I'm trying to do a little bit every day because city code Lambda. And then next time I think I'll do more, you know, Bill Barn. Maybe also Yurik will write something back. So what do I have here? LS notes. Oh, we have the make per. Okay, the make per. So let's go to Nix REPL. Yeah, they should. Sorry. Okay, so we have the select first. It takes 1, takes 2, and outputs 1. So it takes 1. It takes the second thing and gives back the first thing, which calls just the first thing and discards the second, right? Select first, select second, A, B, and B. And then we had make pair, which is A, B, F, like a function F, but this can be a C. It's not a big deal. It doesn't have to be the F. F and then applies that F to the A and B, to the first and the second thing. So now we have make pair, hello, Nix, select first, select second. No, select first. We get a hello. Make pair, hello, Nix, select second. We get a Nix, right? And then we define not. Then we define cond, true, and false. But we defined it like true. It's funny, we already have true. Wait a second, true, yeah, we have false already, we have false. So like true and true gives true, and true and false, false. True and false gives false. So let's define select first. No, let's define true, and we give it. I don't like to put a uppercase on true. It seems like. Let's do our true like this. True is select first, and false is select second. So now we have true and false. So if we do make pair, hello, Nix, and true, we're going to get hello, and make pair hello Nix, and we do false, we get Nix. Now we're going to do cond equals make pair. So now we have cond, let's say yes, no, true. We get a yes. Oh. So we have cond, yes, no, true. We have yes. And how did we define not? Not we defined as a, and this is the abstraction, this is the difficult part of making abstractions actually. You need a lambda head. You need a lambda, you need a head, and you need to bind an argument inside of the body of the knot that we're going to define. And inside of the body of the knot, we have to use a cond, and we have to use a true, and we have to use a false. And this is the abstraction, you know, the difficult. I guess that's very difficult. I was stuck for this. It's not being stuck. It's like seeing this is really difficult. Not difficult. It's so not is a lambda x. And the lambda x is the argument that we're going to provide to the knot. So not something, not true or not false. We're going to provide true to not, right? I don't know if we already have not. Do we have not here? Not true. We don't even have not true. So we're going to have to define the not. And we're going to have to put some kind of ahead, at least one. So we're going to give not an argument, and this argument is going to be substituted in the body of this expression. So far we have just a lambda x and an x, but that's not, of course, the body of this function. But it's something will go inside of this body as an x, and then we will remove this x. So now what remains is some kind of definition of not, right? Because otherwise we just have identity, lambda xx, that's all we have, right? And if we provided something like 2, it gives us 2. But how do we define not as something, you know, not true? We cannot just write lambda xx. We can write lambda xx, but we need here some kind of a function, you know, body, some kind of a body that which will, you know, hold the definition of how this not works. Just as we had make pair, right? We had something like make pair Nix and hello, you know, like you could say yes and no. We had make pair yes and no. And make pair is a function, right? You could even do like x. You don't even have to write make pair, right? You could do x, a, b, c, c, a, b, and yes and no. It's still the same thing. You could write the entire thing like this: a, b, c. So make pair. There is some kind of a function that takes one, takes the second thing, and it takes the third thing, which promises to add a and b, right? This will not make a data structure or something. This will not make a tuple. At first I thought it will make a tuple, which it's not true, right? But then it will just create some kind of promise, like a lambda function. But then you see the a, yes will go inside of the A, and no will go inside of the B. And C, we need to give it a C that will put those yes and no together. No, make pair will actually put them together, but we have to put inside of C something that will do something to that pair. which in our case was select first. And select first is A, B, A. So A, it takes the first, it takes the second, so it will take those pairs, right? But it will just give us A. This will actually give us A. So if we just run this, we should get a yes. This is cool. So one way how you learn this, you make the substitutions, yes, but it's interesting. Yeah, it just takes a while, I guess. And if we had here B, we're going to have a no. So now we need something, but look at this. We have a make pair here, and we have a yes and no. We have two, values that we give it, which could be anything. This does not have to be a string. It could be a number. So it just picks, it makes a pair, and then this substitutes here, and it picks the first thing. So how would the not look like? Now, you know what's weird? The make pair is actually a cond. Well, it's not a cond. It's a make pair that also checks something. And how does it check? It checks if first or the second is true. That's the cond. The cond makes a pair. That's the first, I guess that's the first abstraction layer. It makes the pair. The second abstraction layer would be it picks the first thing or the second thing. Just in our case, you're used the conditional is like if the first thing is true. And that's why the select first was defined as true, right? So this ABA is true because it picks the first thing. So how would the not be defined? How is the not defined? The not is defined as how would you define not? Not is what? Well, it is some kind of a head here. And then, yes, that's the conceptual leap that's so difficult because the not switches it. The not switches it. What does the book say? Not false. Look at this. Not true. Def not. Lambda x. X false true. That's the not. X, so it does not have the cond. Oh, see, I was wrong. She. Well, it does have the cond. Ah, you see, I don't know how to make this simple. It does have the cond. The conditional, make pair false and true. And yeah, maybe this is just too hard. It's like the difficulty level actually, upped. It went up. It really went up. And someone who would jump on stream right now would not understand what's going on. Well, someone would, but not, most people wouldn't, I guess. So the cond false true, cond false true, cond expands, right, false and true. It makes the pair of false and true. That's just this. This is make pair of false and true. And the X is what? True, which is select first. And the select first picks the true. But the tricky part is to make cond false and true, not cond true and false. Before we would making, okay, it's a tricky one. The make pair we did, make pair, right? We did with true and false. But what if you did, of course, what if you did make pair with false and true? It's funny, one part of me does not like this kind of, because you're switching it, manually. So look at this. If we have make pair false and true, and we do select and we do true, it should give us false. Right? True picks the true, but the definition itself it's turned upside down. It's not anymore cond true false, give me the first thing. It's cond false true, give me the first thing, which is false. So it's now cond false true true. What do you mean? I don't have the cond. Didn't we define cond? No. Cond is make pair. Okay. Cond true, false true. And we get a true, right? But if we do cond false true and we give it a true, we get false. So not would be defined as cond what? I cannot put a value here, so I have to provide it. The false is select first. We did already define that. False and true and true. Yes, because we are defining not. I cannot write this because then not would always give me. You see, this is not a good definition. The function itself should take true or false. Like this is just taking, okay, this is like broken not. Let's do a broken not. Cond false true true. So this is broken not. Okay, broken not hello nix. It gives nix. You see what it does? Broken not, broken not, broken not. Let's give it a true. Nothing. Broken not. Let's give it a false. Broken not, false. Yeah, this is probably bad explanation actually. Let's do again. Not equals. So it's cond true and no, we said false and true, and we should give it a true or false. So that's why this is a variable. So what is it going to take that will change? The definition of the body will not change, but the variable will change. The value that we give to not can be two things. Can be either true or can be false, and that's the x. So that means we need a head of the x, and we need inside of the body we need the x. And we could even try it out. So this will be our body, right? That's what we did before. Now this should work. We have got the cond, we have the false, we have the true, and now we should give it some value. Let's give it hello, and let's give it nix, and it doesn't work. Let's give it one value, it doesn't work. Let's give it true. Let's give it false. It doesn't work. Now what if we define not as this thing? Cond false true x. And what if we do now not true? We get a lambda string. Why? Because it's still testing things out. That's what we did. That's how he defined not, and simplifying the inner body gives x false true. So we will use x false true. Oh. The cond false true is a function, but we should simplify it. The false goes inside, true goes inside, and x false true. Lambda x and x false true. It's incredible that I still have to do this. So not is lambda x, x false true. So not true, false. Wait, this is incorrect. Not equals x, x false, true. Not true. Yeah. Let's see if someone answered. Nope. Fascinating. Because he's using not true. Lambda x. Notes. This is the make pair. So we do cond make pair. Then we do true equals select first. Then we do false equals select second. And now we define not as something that makes a pair of false and true. Well, and as a value, right? Like this. Cond false true x. Two viewers. Someone's still watching this. Yeah. The nice thing is I think I've already actually mentioned that. Infinicil system. You can see these things in Nix also. That actually I haven't seen this mentioned on Nix Dev, the Lambda calculus. And when people complain about Nix, I mean that's okay. But I wonder if they see the true value. The true value sounds too grand. You can see these things like, look at these new modules. It's almost like if you want to be too creative with Nix, default.nix. Look at this, recursively constructs an address set of a given folder. Recursing on directories value of address is the file type. So this function, get dir is what? It's like what we're doing with make pair. Look at this. Not is what? Lambda head cond false true x. Get dir is what? Dir lambda head. And now there is a map address, which a mapping kind of a function. So that's the argument. And then inside of the body itself of this function, okay, that's the name of the function, and this is the body itself that represents this name. Then there's the head, and then there is the mapping thing, the mapping function that maps what. And then there are 1, 2 heads. So that means they are going to be given two arguments. And to really, I've said this already, but I'm kind of repeating to myself. The way how do you parse Nix code? It's not just about Nix, it's functional programming, you know? File type, if type, and then inside there is a if type equals what? Directory, then get dir file else. So this is just an if then else statement. Type built-ins read dir. So this is actually, but map address file type. Yeah, and also this files equals what? Dir. So look at this. These are like, you know, this is like Lambda calculus. This is Lambda calculus. Yeah, sometimes I look at these functions. That's for the system configuration from Finicel 7 years ago. And here it imports it, valid files. Yeah, not true. Not true. Lambda x. X false, true, true. It's just, why doesn't, I see that when I would use this, I would use, why doesn't it output not true? Oh, I would have to give it something. No, this is why. Yes. Not. Yes. No. Look at this. No, true. No. Not true. Yes. No. Ugh. I still don't get this, you know? I mean, so not true, not false. If we do the same thing, yes and no, should give us yes. And it gives us the first. Look at this. Not false, yes. Well, let's do it like not true. Like, actually, this is confusing. False. Of course, this is the one I was looking for. This is what I did in the last stream. Not false, true, false. And it's funny, I've heard this already mentioned. Yeah, right. Like, this sounds very, this is so hard when you try to really implement it and understand it and parse it in your head. I guess we are not, something about this is not, like, this is really not hard for ChatGPT. This is interesting. Like, ChatGPT wouldn't make mistakes in this. I've played around with Booleans and LLMs, and that's like really not, so that's more, I think, yeah. This, I guess it's very mechanical, which corresponds to the truth. And you know what? I think because I've been stuck with this, I've been trying to re-explain this. So for already 3 streams, I've been at 3 or 4 streams, I've been at Cond and not. Sometimes it's good to move on. So not to leave stuff behind, but maybe something that I learned now will be more, because you can only try to understand things up to a point and then maybe move on and then come back to it, you know, probably. That's much better. I think that's a good idea. I'll go to AND. Let's do AND. AND is a binary operator of the form. AND is a binary operator of the form. Right, so AND is a binary operator, right? Not is a unary operator that takes true or false, takes 2 things. No, it takes 1 thing. AND is a binary operator because it takes 2 things, which we will describe with a truth table with X standing for the left operand and Y standing for the right operand. So X and Y, so X and Y. So this is not hard. So false and false gives false. False and true gives false. True and false gives false. And true gives true. And okay, So note that if the left operand is true, so basically, yeah, this will always be true, only if both things are true. Otherwise, it's false. There are different ways how you can define this. I think you could do this in Haskell or other functional programming language with pattern matching. So if you it's like something like, if both things are true, then it's true. Otherwise, it's false. So you don't even care. False, 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 true, true, false. Everything besides true and true is false. That's it. It kind of encompasses all the three cases that are possible that way. So it's like you could define all four, write them out. But the better way would be like true and true is true, otherwise, or yeah. So know that if the left operand, but I'm not sure if that's applicable in this case. And let's see how we will define and. Note that if the left operand is true, then the final value depends on the right operand. And if the false, then the final value. It's so weird to read with this movie like music. I feel like I'm in a movie, right? The Iron Dog, fantasy world of Lambda calculus. It's like Lord of the Dragon, and they're going into the Boolean forest, and yeah. Note that if the left operand is true, then the final value depends on the right operand. Yeah, there's so many ways how you can see this, right? Look at this way. And a lot of this has to do somehow with seeing. Like if the left one is true. So if the first thing is true, I guess it's the left thing. I don't know. I guess someone could be confused with the left thing. If the first thing is true, sometimes people get confused by that, like left and right, first and second, or up and down. These are all kind of these abstraction kind of analogies that we used for things that could be described in many ways. If the left operand is true, then the final value depends on the right operand. This is a nice way how to put this. If the left one is true, then the final value depends on the right operand. It's just a different way, right? And if the false, and if the left operand is false, then the final value is false. Oh, look at this pattern. If it's false, actually this was much better what he said, because I was talking about, okay, one thing that I noticed about functional programming, because of the currying. In functional programming, a function takes one thing, and then it takes one thing, it does one thing, and then the second function does the second thing, which you would assume, like you say assume I add two numbers, but you just said two things. In functional programming, a function takes one number, and the second function takes the second number and outputs the addition of the two numbers. Yeah, just a moment. So what I've noticed is the functional programmers talk like that. And it's kind of actually very beneficial. That's the secret. Secret. It's actually beneficial to look at things even in there is some kind of, actually benefit in looking things in life like that. I'm not trying to sound deep here. I'm just mean like when you have a problem that you usually make an assumption, you take too many things at once, and then you have a problem. While in functional programming, you construct everything out of these tiny little, building blocks, which connect in a certain way. So that's how you talk about in functional programming. You talk about how things relate to one another instead of what they are. So, and even at this basic level, and that's kind of helpful when you look at a problem. You look at how it connects and what are the so-called problems in the connections, because usually the problem is not in two things, but in the way how they're connected. The connection itself can alleviate or like can solve the problem, and it's usually it's better to look at the connections between things than the problems, so to say, in the things themselves. Yeah. It's just something I've noticed in all these years that I'm trying to learn functional programming and never managed to do it. But yeah, I went a bit off course, but still, it's because of the soundtrack. Because it's the fantasy open world ambient track. No, but it's true. So what's the and? So you see, okay, the point, because he's saying this, you see this, he didn't say if both things are false, then it's false. I said that before. If both things are true, no. He's saying if the left is true, then the final depends on the right. It's so beautiful. Do you see? It's not the same. If because he's talking about single things. If this single thing is true, then the single final thing depends on the single right thing. That's wrong, of course, but he's talking about this little, units. This entire thing is made out of three things. And this is the final value. So it's not x and y. It's the final value of the x and y. So if the left is true, so what I'm like looking at the way you talk about things, you can even extract this way of talking, not like talking, but thinking about. I think that's the beneficial thing about functional programming, because it indirectly influences, it helps you understand problem domains, like to help to map out things. And I think it's very indirect. It's not like you can, oh, now I'm doing a left thing, right thing, but it kind of helps you in an indirect way to map out or to understand a certain domain. Note that if the left is true, then the final value depends on the right. It's not the same thing as to say if both things are true, then it's true. You see, and also because I'm talking about values. He's saying if it's true, the final depends on the right. So he didn't say the value of this one. Interesting. And if the left is false, then the final depends. Then the final value is false. So and could be modeled using the conditional expression as. It's just x. So how did he get to and? X question mark. Y false. Oh. If the left is true, then the final depends on the right. And if the left is true, then the final value depends on the right. And if the left is false, then the final value is false. So you could say, why did he model it with false? X, yes, of using selectors that we already defined, if the left operand is true, then the right operand, wait, I'm getting lost. If the left operand is true, then select the right operand. And if the left operand is false, then select false. Oh, so we will define and. It's funny, the and. So if the left is false, select the first. You could say this. Okay, because to get this, if the left is false, select false. If the left, or you could say if the left is false, select the left. Yes, he's saying that. Okay. If the left is false, select. If the left is true, then select the right. And if the left is false, select the left. Okay, is this a mistake? No, it's just funny. No, wait, I'm not trying to correct him. But he said if the left is true, select the right. And if the left is false, select the left. But he didn't say that. It's funny. I almost thought he will say that. Like, if the left is true, you select the right. If the left is true, select the right. But wait a second. If the left is true, select the right. Why would you select? Because you already have the information. You know you don't have the information. If the left is true, it could be, still the result could be true or false. If you select, I feel like I could spend years actually studying lambda calculus. What for? If the left, using selectors, if the left operand is true, then select the right. But it can be both. Right, because both are true. So if left is true, select the right. And in our case it's false, then the result will be false. If the left is true, again true, then select the right, which now could be also true, and the result is true. There is probably a mathematical description of, like, if I choose true and false, it will be correct. If the left operand is true. So if the left operand is always true, I guess, I don't know. If the left operand is always true, then select the right operand. Shit. Yeah, I guess maybe it will be helpful. So look at this. If the left operand is true, select the right operand. And if the left operand is false, then select false. So I guess you could say if the left operand is always true, no, if the left operand is true, you always choose the right operand. You always choose the right. And if the left one is false, you always choose the false. There is not much difference, but maybe this always helps in understanding. Sometimes little words like that, vocabulary helps. So we will define and as. Define and. So now we have two heads, right? So we have two heads. How long am I doing this thing? 43 minutes. So now we have an and, right? Do we have an and here? No. We have an and. Let's make it even bigger. We have an and what? Takes one thing, takes the second thing. I guess you could do x and y, and x and y. Right, so it will take the first thing and the second thing, and of course it needs to have the space for those arguments. But still, we need a body. We need something here. So we need some kind of a function here. And x, y, and we need some kind, it needs to do something with those x and y's. What is it going to do? Let's see if someone wrote something back here. Nope. Probably Frikla Hanweg will write something. Yeah, let's see. So we have a lambda x and a lambda y, and now a cond. Oh, it's gonna use the make pair. Make pair. Okay, well, I already see I'll have to. So our and is going to have a two heads, and then we have a make pair, a y, and select second. Actually, let's have select second x. So this is going to be our and. Look at this. X and y make pair y. So make a pair of what? Make a pair of the second. Make a pair of the second operator. Right, second operator. Let's look at the truth table. The second operator. True, true. False, false. True, false. False, false. So if we look at the second operator, it always stays the same except when the second operator is true and the first is false. So make a pair of the second operator and select second x. Yeah, this is too much. I think this is too confusing. For some people it may not be confusing, but for most it is, because I think there must be some kind of cognitive, limit of how many make pair y select second xy thing you can do. Probably this was like, doing an assembly language. Okay, in one sense, what we're doing now is an assembly language, well, like functional assembly language, which is lambda calculus. That's the assembly. I think that's the assembly. I don't know if people call it like that, but it is assembly language. Like imperative languages have that, their assembly. But the lambda calculus is the assembly language. Well, let's see what he did, because this sounds so, but he's defining it again, and lambda x, lambda y, and cond. Maybe we could try it in the REPL. So we have an X REPL. Okay, and is what? And is simplifying the inner body. Okay, so we'll simplify the inner body actually. Let's write it out. Okay, I will actually do what he does. Cond y false x. Should I put the parentheses? I don't need them, but maybe, yeah. And so what do we have? Cond y false x. So he's first actually simplifying the inner body. He's simplifying this, and then he will add it to the heads. So right now he's just gonna concentrate on simplifying cond y false x. Let's simplify it. Cond, okay. All right, are we ready? So cond is actually make pair. Right? Cond is make pair y, and false is select second x. Now make pair, let's, what is the function body of the make pair? Well, A, B, what is he using? He's using E1, E2, and C. Okay, let's do like E1, E2, C, E1, E2, Y, select second x. Right, false. Now what do we have? We have select second. Well, y is the first thing. Y is the first argument. Y will go inside of E1, not C. Y is the E1. Look at this. Y, E1 is the first head. So Y will go inside here, inside of the E1. And we will remove the E1 head, which will leave us with E2, C, C, E1, we have Y, E2. And this, let's put it like this. And then select second x. So now we have E2C, CY, E2, select second x. Now what is he going to do? Now he's going to have to put select second. But wait a second, 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 wait a second. False. Yes, a function is going to go, but not into C. Fascinating. Because if it select second, go inside of E2. So we'll leave us at C. Y, E2 will now be select second and X, right? So now C, Y, select second, X. Now X will go inside of C. But since there is no C inside in the body, we discard X. We discard X. No, you don't discard X. There is a C in the body. Why would not there be C in the body? I think I made a mistake. Oh yeah. No, no, it's CY selects second X. So X goes inside and then we have XY select second. That's what we get, XY select second. And select second in our case is XY false. So now we will use now and it looks like this, XY, XY false. So X, Y, XY, false. So that means true. That means, how would we do that? And yes, no. Or like yes, is it like and no? How would we call it? True and false. And true, false. No, let's do and true, false. This works. I get it. Look at this. I do and true, false, and I provided. Will this work? Fascinating. We got it. Look at this. And true, true, yes, no, yes. True and true gives yes. Gives true. Okay, let's do it like this. True and true gives true, and true and false will give false. And true, what is and? Also we have it here. Yeah, nice. And true and false. And false and false gives false. Fascinating. Probably next time I'll forget this. But wow, true and false. You can even and true false. Look at this. So if I were to write here and, so I have to give it a value, of course. Otherwise, you can't just write true and true, right? You have to give it a x and y. Look at this, true and true, x and y. Now, if and is, look at this, let's expand the body, x and y. Actually, let's not give x and y because we'll be confused. Let's do a and b. X and y false. True, true, a and b. Gosh, this will take a while. Now, true goes inside of x. So we get y, true, y, false, true, y, false, true, a and b. Now, true will go inside of y. True will go inside of y. Oh, true will go inside of y. So we get a true, y is true, and we got a false. And now, look at this. Now we're going to give it, finally we're going to give it a value. Now a, oh, of course. True is also defined in a way. So true would have to expand now to true prime. The true prime that I would have to expand it to a, b, a. Let's actually change this to Q and P. Q and P. P and Q. P and Q. P and Q. So A, B, A. We expand A, B, A. True, false. P and Q, right? So what's going on now? Maybe true will go inside of A. It's funny, it's like true is going inside of true. True will go inside of A. True will go inside of A. Exactly. And we'll substitute the A. We'll actually have a B and true and false. Right. And then we have a P and Q. But now look at this. We have a B, true, false. False will go where? Nowhere. If false goes inside of B, it's going to go down. So we're just going to remain with true, P and Q. And what's true? True is A, B, A. P and Q. And P goes inside of A. We get a B, P. Yeah. And we get a Q. And Q goes inside of B. There's no B in the body, so we get a P. P is the definition. So N, true, true, P and Q. N, true, true, P and Q gives out true, gives out P. Maybe this is actually beneficial for the mind. I think it is. Otherwise, you get to a point where you say, why would I do this? This is really useless, and But I think it's helpful. I think, instead of like children do those mechanical kind of silly, you know. My wife works as an assistant in a school, and she showed me some of this. And one of the things she's helping someone like in math, and they do these mechanical algorithms where they have to save things in their head, and they're not really. I don't know. They're so old. It's like they're coming from. I heard Bartosz Milewski saying that the category theory guy was saying that that's from the industrial times or pre-industrial revolution times, where I had to do all of these mechanical things, and humans are not for that, and that's for the machines, and we should do more abstract math, even like designing and relations and functions and whatnot. But maybe this will be interesting to do in school. Yeah, I think this is it for today, basically. I want to make a screenshot of this, actually. I think I'll use this for the cover of the video. That'd be nice. And at least we did and today. I'm kind of happy with this. I'm happy with this, yeah. And 1 hour and 1 minute, that's perfect. That was today Lambda calculus, and thanks everyone who dropped by, and all best. Have a nice day.